In this lecture, we're going to see one example of the addition of vectors, three vectors in fact. Each of the three vectors can be regarded as a displacement. A hiker, for example, undertakes a three-part journey, executing one displacement, pausing, then changes direction and distance, and repeats. The three vectors that represent our displacements are shown in this table. Displacement A, B, and C, distances are given, and headings are given. Remember, headings are angular measures relative to the north direction, which we take to be the positive y-axis. Our first vector, vector A, is shown in this picture, 100-meter long vector A. Its heading is 40 degrees. There's your north axis, which we describe as the positive y direction. The angle between the vector A and the north direction is 40 degrees. The complement of that angle is 50 degrees, which we may put to use and we may not. Vector B is 80 meters long. Its heading is 200 degrees, which means it's 20 degrees more than 180. 180 degree heading is due south. Add 20 to 180 and that gives us the 200 degree heading. I show the complement of 20 here as 70 degrees. We may use it, we may not. Finally, vector C, 60 meters long. Its heading is 300 degrees. 300 degrees is 60 degrees short of 360, which is one round trip around the clock. And so we have 60 degrees short of north. Complement of 60 is 30 degrees. We seek to add these three vectors to find the net displacement. We first find the separate x components of A, B, and C. A sub x, shown here, is the hypotenuse, 100 meters, times the cosine of 50 degrees. B sub x is the hypotenuse 80 times the cosine of 70, but it's a negative sign because the shadow created by that arrow due to a light shining upward from below would lie along the negative portion of the x-axis. Hence there's a negative sign there. The x component of C, there's your hypotenuse C vector. That angle is 30 degrees. The projection of that vector on the x-axis, owing due to a light up here, will lie along the negative part of the x-axis and is equal to 60, the hypotenuse, times the cosine of 30, negative 60 cos 30. You can do the same sort of thing, and I won't go over all of that, for the y components of the three different vectors. You may have already had enough practice finding components from a previous lecture. And so let's get to the heart of the matter, which is determining the sum, the vector sum of those three vectors. We'll call that vector sum S, remind you of the word sum. And S is equal to the sum of those three vectors. To find the length of the S vector, which is symbolized as S without an arrow, we find the two separate components of the S vector, square them, add them, take the square root. So we need to find S sub x and S sub y. S sub x is the sum of the three separate x components, which I work out to be negative 15.04 meters. S sub y I find to be 31.43. You need to square each of those numbers, add them together, take the square root, and this is what I get. Final result for the distance from the starting point to the final position after the third displacement is undertaken, 34.84 meters. Now, a second hiker starting out at the same location, initial location as the first hiker, would have to travel that many meters along a particular heading. The heading is found by drawing the S vector and its separate components. Theta there is the angle between the north direction, which is the positive y-axis, and the S vector. And so when we can calculate theta, it'll represent the heading along which that second hiker would have to travel. And we get from this SOHCAHTOA, theta, same as that theta, is up. The tangent of that angle is opposite over adjacent, shown here. Theta is the angle whose tangent is that ratio. Final result, once and for all, the heading is 25.57 degrees.